Okay, so let's just have a tiny review here of y equals x squared and y equals negative x squared. So we know that 0, 0, 1, 1, and 2, 4, and negative 1, 1, and negative 2, 4 are the 5 major points of y equals x squared, right? Now I want you, instead of remembering these values, like 1, 1, and 2, 4, I want you to just remember the point 0, 0, and I want you to just remember this pattern. From here, you're going to go over 1 and up 1 and make a point, and then from there you'll go over 1 and up 3 more and make another point. So I'm just going to draw the path of your pencil. So you make a point for the vertex, then go over 1, up 1, make a point, and then go over 1, up 3, make another point. And then you'll do the same over 1, up 1, over 1, up 1, 2, 3. And that's how I want you to draw your parabolas from now on, just using the over and up. So it's over 1, up 1, and then over 1, up 3. You're always, when I say over 1, it's because you're only just going over to the next x value. So what's important is up 1 and up 3. Okay? So here, when we do y equals negative x squared, we know we're going concave down. So we're still going to start here, and instead we're going to go over 1, down 1, over 1, down 1, 2, 3, over 1, down 1, over 1, down 2, 3, and there's our graph. Ta-da! Okay, so now that we've talked about this over and up and over and down business, I want to take a look at this. So we took a look at the reflections, what happens when A is positive and negative, and we took a look at moving up and down. Let's take a look now at stretches. So if our basic curve is 0, 0, over 1, up 1, over 1, up 3, y equals x squared, I want to make our new y values double these y values, right? And when I double these y values, well, let's see, this y value is 1, so now it'll be 2. And this y value is 4, so now it'll be 8. And when I'll just draw the other ones here. So now when I draw this curve, it's way steeper. And this is the equation. Now, I just want to show you something. To get from here to these points, I went over 1 and up 2, and then I went over 1 and went up 1, 2, 3, 4, 5, 6. So for y equals x squared, we go over 1, up 1, over 1, up 3. And for y equals 2x squared from the vertex, wait a second. Got to go backwards here. We're going to go over 1, up 2, and then over 1, up 2, 4, 6, because we're doubling these ups, because we're making it twice as steep. So that means, again, we don't need to plot points. For here, for 3, we know we just go to our vertex, we're going to triple this. So we'll go over 1, up, triple that, 3. And then over 1, triple that, up 9. So let's see, from our vertex, we're going to go over 1, up 3, and then over 1, up 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we're going to use symmetry to get the other points, and then we're just going to connect our points. And that's the graph y equals 3x squared. Now, it works the same way if you're picking a number between 0 and 1. We know if we pick a negative number, that doesn't have anything to do with the shape of the curve. It has to do with direction, opening, and up and down. But between greater than 1 will be a stretch, and between 0 and 1 is going to be almost like you sat on it and like it's wider. So we call that a compression. This is a stretch, and between 0 and 1 will be a compression. So instead of going over 1, up 1, when we have y equals 1/2 x squared, we'll go over 1, up 1/2, over 1, up 1 1/2. So that'll be 1/2, And that'll be 1.5 because those are half of 3 and 1. So here, over 1 up a half, over 1 up 1.5, over 1 up a half, over 1 up 1.5. And then you have this graph here. So it's getting a little busy on this coordinate plane, but you get the idea. It's all these values of a, or the number in front of the x squared, will tell you if your a is greater than 1, not equal to, sorry, just greater than 1, you know it's going to be a stretch. And if it's in between 1 and 0, it's going to be a compression. And you know that if a is less than 0, it's going to be a reflection and concave down. But whether it's -0.5 or -2 or -6, it's going to tell you how steep or compressed the graph shape is going to be, even though it'll be opening down. And let's try some of those. Together. So here I have a question where we have this stretch or compression, and we also have this shifting up and down. And just like in English, how we read left to right, we do math left to right as well. So what I'm going to do is I'm going to show you how I do this all together. So I'm going to know that starting at 0, 0, I'm going to go over 1 up a half, over 1 up 1.5, over 1.5, over 1, 1.5. And then I'm going to shift all those points, and it's concave up because that's positive. And then I'm going to shift those points all down. 1, 2, 3, 4. Over 1 up a half, over 1 up 1.5. And that is my graph. End of story. Y equals 1/2 x squared minus 4. I know it's hard to see with the grid being so dark, so let's do another one over here. Here, we're going to graph y equals -2x squared plus 8. Okay, so I know I'm going to be concave down because of the negative. I know I'm going to be over 1 down 2, over 1 down 6. And I know I'm going to start at +8. So 2, 4, 6, 8. So at +8, I'm going to go over 1 down 2, over 1 down 2, 4, 6. And then I'm going to do over 1 down 2, over 1 down 6. There's my graph. That's it, folks. That's all I need to be able to do. So let's do another one right here on this grid. How about we do, actually, sorry, I forgot to write down the equation beside the graph. How about we do y equals 1/2 x squared minus 2. Okay, so I'm going to go concave up. I'm going to go over 1 up a half, over 1 up 1.5, and I'm starting at -2 on the y-axis. Over 1 up a half, over 1 up 1.5. Oh my gosh, what a coincidence. It lands right on the same points of the other curve. Oops. And there we have it. So again, if you can decode what these things mean, the negatives, the numbers, and so on, you can just go to the vertex, the highest or lowest point, and then do your over and ups or over and downs, and you're done. Pretty neat, huh?